Okay, hi everyone. Last lesson of the week, and we're sticking with straight line graphs. We're just moving on a little bit. So we're going to start off looking at intercepts, and we're also going to look at gradient this lesson. So the intercept is where the line crosses an axis, so either the x or the y. So when it crosses the y-axis, we call it the y-intercept. When it crosses the x-axis, we call it the x-intercept. So when we're working this out, there is a shortcut we can use, which we will start to use later on. But for now, I just want to think about why that shortcut works. So when the line crosses the y-axis, there's something that we know about the y-axis to do with the values x and y. So what is the x-coordinate going to be when it hits the y-axis? Well, everywhere on the y-axis, the x-coordinate is 0. So what that means is if we substitute in x is 0 into our line equation, that tells us the y-intercept. So if we substitute in, and we get that the point is 0, 6. So similarly, on the x-axis is just the point, the line where the y values are always 0. So again, to work out the x value, we substitute in y is 0, and we can work out the coordinates from that of the x-intercept. Okay. So similar, this is just an extra example, and the equation is slightly different format. So with this, to work out where it crosses the y-axis, that's the point where the x is 0. So we set x equal to 0. We get 2y equals 3. So then we rearrange to simplify to work out what y is, and we get 3 over 2. For the x-axis, we set y equal to 0. And work through that to work out that the x1 is 3. So there's a couple of things here that are really common mistakes. So putting the x and the y the wrong way around. So thinking that you're crossing the y-axis and then accidentally setting y equal to 0 rather than x. That's a really common mistake. So that was the second one of those two. And when you're writing out the answer with the coordinates, putting the coordinates the wrong way around is the other mistake. So two really common ones to look out for there. Okay, so if you're feeling pretty confident with this from just the first discussion, feel free to go and have a look at the Dr. Frost section on this on the website. So that is questions 1 to 6. So if you're feeling confident with that, feel free to go have a go. I'm going to go through it now anyway on this. So if you want to pause the video, go have a go at questions 1 to 6, that's fine. You don't have to watch this bit. If you are sticking around for extra examples, I'll go through them now. So we've got this first one, y equals 3x plus 1. So on this one, the point where it crosses the y-axis, so if it's on the y-axis, that is the points where x equals 0. So on this, we're just going to substitute in x equals 0 here. So because it's then 3 times 0, we just end up with y equals 1. So our coordinates would be 0, 1. And where it crosses the x-axis, that is where y equals 0. So we're going to then substitute in y equals 0, and we've got 0 equals 3x plus 1. We then take 1 from both sides to get minus 1 equals 3x. And from then, dividing by 3, we get minus 1/3 equals x. So our coordinates would be minus 1/3, 0. So a little bit more complicated on this one than the first section. Okay, next one down, we've got y equals 4x minus 2. So where it hits the y-axis, that is where x equals 0. So we set x equal to 0. So that'll vanish, we just end up with y equals minus 2. So now we can just write the coordinates 0, minus 2. This one, again, a little bit trickier. So it's where it hits the x-axis, so we're setting y equal to 0. So we're going to write out 0 equals 4x minus 2. So adding to both sides, we've got 2 equals 4x. So half equals x. So our coordinate would be half 0. So you'll notice at this point, this column is quite a lot easier than this column, and that is because of how the equations are laid out. They're laid out as y equals something x. plus something. So these three, you'll notice that the first column's a bit easier. This one, you can see the format's changed, so the x and y are on the same side, so they'll be as hard as each other. Okay, so this one, we're setting x equal to 0 again for the first one. So we just end up with y equals -1. So our coordinates would be 0, -1. And the second one, we're setting, it's crossing the x-axis, so we're saying y equals 0. So we've got 0 equals half x minus 1. So that means 1 equals a half x, that's adding 1 to both sides. So that gives us x equals 2. So our coordinates would be 2, 0. So just to draw the attention to these first three, we can see in this first column that the y coordinate, so the x is always 0 because that's the y, it's the y-axis, and the y coordinate, that is always just this second number. So just a little shortcut you can use there. Right, so on the y-axis, we're going to set x equals 0 here for this last one. So this term will vanish, we just end up with 3y equals 4. So y equals 4 over 3. So our coordinates 0, 4 over 3. And for the x-axis, we set y equals 0, so this term will vanish. So 2x equals 4, x equals 2. So our coordinate would be 2, 0. Okay. So moving on now, we've done some intercepts, we're going to have a look at the gradient. So this will make up the sort of bulk of the lesson. Let's have a look at another one. So we've got y equals -1x plus 2. So let's do our table of values. So we've got y equals -1x plus 2. And you can see that each time as we go across 1 in the x direction, we're going down 1 in the y direction. And last one of these, so we do our table of values. We've got our straight line. So we've got y equals a half x plus 1. And we can see that for every 1 we go across in the x direction, we're going half upwards in the y direction. So the number in front of the x, that tells us how steep the line is. So that tells us for every 1 we go across in the x direction, how much do we change in the y direction. And this is called the gradient. So the steepness of the line is known as the gradient. It tells us what y changes by when x changes by 1. So if we move 1 in the x direction, what does the y change by? And so this sort of formula here, y equals mx plus c, this is a really important formula. This will be really important all the way to GCSE and A level as well. So this number here, the one in front of the x, that tells us the steepness of the line. So that is the gradient. So the gradient is m. So whatever number in front of the x, when it's in this form, that tells us how steep the line is. And as we saw before when we were looking at the intercept, you can use the shortcut. If you look at just this number at the end, that tells us the y-intercept. So I've got 2 bits of information from this one equation. Right, so what I would like to see now is on the sheet that's attached on Firefly, you should have this task. What I want you to do is go through and work out for each of these lines what the gradient is. So you can do that if you know a method already, that's fine. If you want to use the method we've just done, which is where you look at how much y is changed by when x goes up by 1. So I'm going to do this first one, so I'm going to do A on here. So if you want to pause and just make a start, that's fine. If you want to watch me go through the first one, that is also fine. So we said the gradient is what y changes by when x increases by 1. So I'm going to pick a point on the line A, I'll pick down here, but you can pick any point, you will get the same answer. I'm going to go across 1 in the x direction. So I've done that there. And then I need to see what y has changed by. So I've gone across 1 in the x direction, and I can see that y has changed by 1 as well. So that tells me that the gradient of A is 1. So that's quite straightforward, because I've gone across 1, it's gone up by 1, so that's nice and easy. I'm going to just do another section on A as well, just to sort of clarify. So I'm going to pick another 2 points. So I'll pick here and here. So I can see now I've changed it by 2 in the x direction. So I've gone double as far in the x direction. Because it's a straight line, if I go 2 times as far in the x, I should go 2 times further in the y direction as well. So if I've gone across 2, I've gone up 2. So how would I go from 2 and 2 to get to my gradient of 1, which I know the answer is? So what I would do is I just work out, so if it's gone up by 2 by going across by 2, to work out what the gradient is, I divide the change in y divided by the change in x. So gradient is change in y divided by change in x. And what that works out is, for each one I go across, what have I changed in y? So I've got 2 divided by 2, which gives me 1. So I can see I get the same answer doing this. So wherever I work it out on the line A, because it's a straight line, I'll get the same gradient. So what I want you to do now is go have a go, practice with the others. The answers are also attached, so check your answers as you're going along. I think G and H you should get fractional answers as well. I can't remember if any of the others are fractional, but G and H I'm pretty sure are. Okay, so let's say we have 2 points on the line and we want to work out the gradient, but we didn't want to draw a grid out. How could we do that? So what we're going to do is, we've got the grid here, we're going to see how we could do it without. So we see x is increased by 4 and y is increased by 6 to go from this the lower coordinate to the upper coordinate, so this coordinate to this one. So y is increased by 6, x is increased by 4. So what we can see, when we're looking at gradient before, we were saying if you go 1 across, how far up does it go? We can see it's about 1.5. But we're going to see if we can do it without using the grid. So how would we work out the gradient of 1.5 without using the grid? So what we're going to do is we look at the change in y and the change in x. So we've got the change in y is 6. And the change in x is 4. So to work out the gradient from this, we do gradient of m equals change in y over change in x. So that gives us 6 over 4, 3 over 2, which is 1.5. So that's what we thought it was, using this way. So the way we do it, if we want to work it out from 2 coordinates, we do the change in the y coordinate divided by the change in the x coordinate. So that's what we're doing over here. So this question, if you want to watch me do this, feel free. If you're feeling confident, you can go straight on to the Dr. Frost one. So this is, on the website, it's question 7 to question 12. So that's all ones like this. So working out the gradient, we do change in y divided by change in x. So I'm going to call change in y, I'm going to use delta y and delta x, just because it's quicker than writing change in y and change in x. So delta y equals, that's 10 minus 4, which is 6. And then change in x is 3 minus 1, which is 2. So my gradient, change in y divided by change in x, so 6 divided by 2, gradient is 3. So just be careful when you're doing this, that if you're taking away from this one to work out the change in y, you also need to do it taking away this one from this one, if you've taken away this one from this one. So make sure you're basically taking away the same way round each time. So you'll see what I mean with this one. So I've got 1 going to 7, so I'm going to do 1 minus 7 to work out the change in y. So change in y is decreased, so it's minus 6. Change in x, we've got 8 and 5, So that's increased by 3. So my gradient, changing y divided by changing x, I've got minus 6 divided by 3. So my gradient would be minus 2. So you can see you can get a negative, and that's why it's important you make sure you subtract the right way around, or a consistent way around. Okay, so this one, I've got 10, I'm going to take away 2. So changing y, it has increased by 8. Changing x, so that's gone from 2 to minus 1, so that has decreased by 3. So my gradient here would just be 8 over minus 3, or minus 8/3. So you can get fractional gradients, that's completely fine. Okay, so the last thing for today is working out the gradient just using the equation of the line. So far all the ones we've been using either coordinates on the line or the graph, but we can do it just using the equation of the line. So the way we do that is we rearrange it into the form y equals something x plus something. So if we rearrange it into the form up there at the top, y equals mx plus c, then whatever number is in front of the x, so wherever the m is, that tells us the gradient. So what we need to do is all just about rearranging it to get it in that form. So I'm going to go through a few here, but if you're confident you can do this already, feel free to have a go. So this is question 1 on the sheet. So the same sheet that had the graph of lines that you had to work out the gradient of. So over here we've got y equals 2x, y plus 2x equals 1. So we need to get it into the form y equals something x plus something. So the way we do that, we need to get the x to the other side. So we're going to subtract 2x from both sides. So we end up with y equals minus 2x plus 1. So our gradient then, whatever number is in front of the x, it's minus 2. So gradient equals minus 2. Okay, so let's go over to this one. So we've got 2y equals x plus 1. So we want it just to be y equals, so we need to divide by 2. So we end up with y equals, so we've got a half x, and we've got plus a half. So now looking back at the equation of the line, what number is in front of the x? A half. So that tells us our gradient equals a half, and again, completely fine to get a fractional gradient. So if you want to pause the video now, have a go at these ones, have a go at that. If you want to just watch me go through a few more examples, that's fine as well. If you're feeling confident, you can make a start on the sheet, just make sure you're checking your answers as you go. So we've got y equals 1 plus 3x. This is actually kind of already in this form, it's just the constant and the something x have swapped places. So you don't really need to do much with this, but if you want to, you can rewrite it as y equals 3x plus 1. So all we've done there, switch those two around. And then whatever's in front of the x is 3. So our gradient is 3. So that one we didn't really need to do that. We could have just looked and seen it was in front of the x. But if it makes you sort of more comfortable with it in the usual form, you can switch around and that's completely fine. Right, so this one, you can see we've got a minus y, whereas in our original equation, the sort of general one, it's not a minus y. So what we're going to do is add y to both sides. So we've got x equals 1 plus y. And then, again, looking back at the general form, we can see that y is on its own, so it needs to take away 1 from both sides. So end up with, and I'll just swap the sides as well, so y equals x minus 1. So in fact, I'll do it in 2 steps. So we've got x minus 1 equals y, and then we just swap now to y equals x minus 1. So with this one, we don't have a number in front of the x. What that means is it's just 1, because it's one lot of x. So our gradient here would just be 1. And last one, and I think the trickiest one on here, so we want to get it, we can see we've got the x's and the y's on the same side, so we need to sort that out. So we'll subtract 3x from both sides. So we've got 2y equals minus 3x plus 4. And then we've got 2y, we want just to get y on its own, so we're going to divide by 2. So we have y equals, so that'll be minus 3 over 2 x plus, and then 4 divided by 2 is just 2. So now we look in front of the x to tell us the gradient, so we've got m equals minus 3 over 2. So now this is the last thing we need to be able to do today, so that is question 1 on the sheet. If you do feel like the sheet's pretty straightforward, you're confident with it, feel free to carry on with it. There's question 1 and question 2 on there. Question 1 I'd like you all to have a look at, but if you sort of race through it in the time, feel free to have a look at question 2 as well. There's also the killer questions, which again are quite a lot above what we need at the moment. If you want to have a go and you've got time, have a go at them as well. So this is the exercise. This is on a separate sheet, but if you want to work from the video, that's fine. So just doing question 1 as the sort of essential stuff today, but if you do finish that early, you can get some extra practice on these ones. I probably wouldn't bother having a go at this. It's a bit, either it's too straightforward or it's too hard, depending on how you do it.